The question on the screen has been sent to us by Vilit Mukhadi. Vilit, thank you for this question. It deals with optimization, so finding maximums or minimums. Now the question says, I'm going to read the question. There's a metal frame. The metal frame consists of 4 congruent rectangles and a semicircle. There's our semicircle. So immediately we can add to the information. If this is X, that will be X. All of these are X's. This is an H, that is an H. All of these are H's. We've got 4 of those congruent rectangles. And then we have an X here and an X there and our center of our semicircle over there. Good. Now I've put the 2 questions on the screen with a reason. They ask us for, there's no mark allocation. They ask us to show that the length of wire that is needed to make this frame or steel that's needed is given by that expression. But they also tell us that the length of steel has a total of 36 meters. Okay, so just imagine that. You have 36 meters of steel that you must chop up and bend to form this window frame. Let's call it a window frame. Okay, and then the length in terms of H and X is represented by that expression. It says, show this. And then they also ask us to show that the area of this window frame, the total area, is given by this expression. Now notice that this expression only have X's in it. Okay, there's only X's in the area. So somehow the H is going to disappear. Okay, let us start. I'm just going to make space here for us. Let's just move this down a bit. Let me just grab it again. And we're going to move it and make space for ourselves. Okay, there we go. So our first length that we have, I mean, they told us the length is 36. Okay, so how many H's are there? There's 1, 2, 3, 4, 5, 6 H's. So the length has 6 lengths of steel with height H. Then there's 1, 2, 3, 4, 5, 6 of length X, and then pi times X. Now that can only be this semicircle here at the top. Okay, so the semicircle that we have, usually the semicircle will be pi 2 pi d. Okay, or pi d, 2 pi r rather. Okay, so what is that semicircle going to be? The full circle is 2 pi r, so the semicircle is half of that. So it will be half of 2 pi r, and r is the radius x. Okay, and we can see nicely that the 2's take care of each other, and we have 6h plus 6x plus the pi x at the end, which is exactly what they told us it would be. Now, folks, the reason why they gave us that expression is for the second expression, the area of this window frame, there's no h. So if you could not get to the expression by yourself, then you would be lost in the second half. So if you could not get this expression that they've given you, and you got something silly here that says something else, then just use what they've given you to go further into the question. That's why they give you these little pit stops, if you want to call it that, in the question itself. Okay, let's move to the second part. The second part says, show that the area is given by this expression. We've already identified that there are absolutely no h's in here. So what did they tell me about h? They told me the length of the frames, so we can go but L is equal to 26. It was given 36, not 26. L is given as 36. Okay, let's write that down. But what was L? L was 6h plus 6x plus pi x over here. So all I need to do now is work with that side. If I divide this whole thing by 6, because there's this common factor of 6. Remember, I'm trying to get this by itself. So I get that 6h is equal to 36 minus the 6x minus the pi x over there. Divide the whole lot by 6. Then I get that h is 6 minus x. Remember, 36 divided by 6. 6 divided by 6, and then minus pi over 6 x for the value of h. Okay, so that gives us our height. Now remember, what is the area of this expression? We've got the area given here, but we need to show that it is indeed this. Okay, so let's see. The area in terms of h and x, both variables, will be, let's count again, there's 4 congruent rectangles. So the area of each of those rectangles, so this will be 4 times the height of each one is h and the base is x. So there's 4 hx's, 4 of those, plus then the area of the semicircle at the top. Now the area of a circle is pi r squared. It's half a circle, so I divide it by 2. So this will be pi x squared divided by 2. So remember, that represents the semicircle and its area. Okay, now what I have to do is put the h in. Go slowly, folks. You don't want to fall over a simple little trap that the question is setting for you. So look at how I'm writing this. The area in terms of x is now 4x multiplied by h, and h is 6 minus x minus pi over 6x. Okay, that's h, plus then the pi x squared divided by 2. Okay, let's make some space here. This will be 24x. This is going to be minus 4x squared. Over there, I have a plus times a minus, so minus. Now 4 goes into 6, simplifies to 2 pi over 3 x squared over there, plus pi x squared over 2. Okay, so what have we got so far? We have the 24 and the 4x squared. We must just simplify this over here. So we get 24x minus the 4x squared. Now we have minus. Now I'm going to change this LCD of 2 and 3 is 6. Okay, so I'm multiplying the top with 2. I multiply the denominator with 2, here with 3, and there with 3. And I'm going to write the answer down. I'm not going to show that I'm multiplying and then going to add. So this is minus 4 pi x squared plus 3 pi x squared is minus pi x squared over the LCD of 6. Now, folks, let's have a look. Minus pi x squared, where is it? Over 6 is what they wanted us to show. There it is. We've got that. We've got that. Our area is indeed perfect. Now, please remember, you saw all the amount of fractions that happened in that question. So do it slowly so you don't fall into the traps. The last part of the question says, hence determine the length of the base. So the third part, part C, is they're asking us the length of the base. Now be careful. The length of the base is split into 2 x's but I need to find x, and I need to multiply the x by 2. That's what I'm looking for. Okay? Under the condition that the frame has a maximum area. So we've got to take the area expression. Remember, like when you drew the graphs, the stationary points lie where the derivatives are 0. Those stationary points were either local maximums or they were local minimums. Hence the idea of optimization. We can use this, we use exactly the same principle. Okay, so let's go. Our area in terms of x needs to be differentiated, first of all. Here, all our x's are at the top. So I can go and differentiate immediately. The derivative of 24x is 24, minus 4 times 2 is 8, with an x over there. And this 2 comes down, 2 divided by 6 gives me 3 at the denominator. And then I have pi over 3x that's left. That is equal to 0. Why is it equal to 0? Because we are optimizing. To optimize this, we take the area derivative and we solve it equal to 0. Okay, let's have a look. If I now multiply, let's see. No, let's just get the x by itself. It's going to go quicker. So this goes to the one side. So I end up with 8x plus pi over 3x, which is equal to this 24. So what is x? I remove it as a common factor. I have 8 plus pi over 3, which is then equal to the 24. So what is x? X is 24 divided by 8 plus pi over 3. Now, folks, you can multiply the top with a 3, and you can multiply the bottom with a 3. You're multiplying by 1. That takes care of this ugly fraction. So that is 60 plus 12 is 72 divided by 24 plus pi. Okay, so let's bring our calculator up and we calculate what that result will be. 72 divided by, now remember, use brackets, 24, and it's added to pi. Now pi is over there, beautiful. I press my equal sign, 2,65. Okay, so let's write this down. This is equal, approximately equal to 2. I say 2 and I write a 3. How crazy is that? 2,65. I put approximately because I took it correct to 2 decimals. Okay, now folks, all we need to do is go back to that and tell the calculator to take that and multiply it by 2. So 5,3 is what I'm left with. So the base is 5,3 meters long. Okay, so what did we have to do? We had to find the length. They gave us the length. We just had to confirm that. Then we took that length. We made it equal to the 36 that they told us to find h by itself. The question was then asking us to find the area. We saw that the area would be in terms of h and x. So we had to go back to the length. We had to use the length expression, make L36 get h by itself. Once we've done that, we went to our area expression, replaced the h with whatever it was equal to in terms of x. That left us with the area in terms of x only, that we could differentiate, make equal to 0, and the last trap that was set for us is that they asked us for the base length. Now the base consisted of 2 x's, so I had to multiply my answer by 2. Okay, so that was a beautiful question that was given to us by Villet. Villet, thank you for that. This type of question is usually anything between 9 to 12 marks in the paper. So make sure that you can optimize.